So if I put 3 volts here on the battery, it will have 0.6 ampere. Of course, the resistance are all the same, 5 ohm. Okay. Let's take example. If we have 1 volt, we want what the current. If I have 1 volt, I want the current. What should I do? It's fall over resistance. So 1 over 5.0, it will give what? 0.2, right? Another example. For example, I have resistance 12 ohm. I have resistance 12 ohm, and then I have, for example, I need the current. I have a voltage 24 volt. So what is the current? It's V over R. It's 24 over 12, and is 2 ampere. Okay, so we keep going. How we see now in the paragraph here, what's going at each point here, it's going together. Okay, so we understand from this that the voltage and the current are always together. So if the voltage is rising up, also the current is rising up. Okay. So let's take the current potential graphs. For here we have a tungsten filament. So when you're applying more volt here, what will happen is the current will go in this way. As you can see this figure in page 185, you can see it here, the left one. So you can see here the temperature for the filament is now 1500 Celsius, but then it's rise like this. So why? Because the filament needs time to warm up, right? Or more, it's not going sharp as the nichrome wire, so it's always also it's related to the nichrome or the tungsten filament resistance. So it will go in this arc way. Okay, until it's here, it's about 3000 Celsius. Here we have also another example about the current and the volt, but now for the semiconductors diode. So the diode is always give forward. It's okay, you see it as an open gate forward, but when you give reverse, it's almost zero, so it don't give you any power. So we see here it's giving you supply from 0 with positive voltage, so it's coming until 0.6 volt. It will rise up and then the current will pass. But if you give it another other way, it will almost don't pass at all.